Hi, Louis Martin.
Hi, Anna.
How are you?
Good, very good.
It's a pleasure to have you here today.
Thank you. Yeah, it's a pleasure for me too.
Yeah. So today my guest is Louis Martin Rousseau. He's a full professor in the Department of Mathematical and Industrial Engineering at Polytechnique Montréal, where he has been a faculty member since 2003. He holds the Canada Research Chair in Healthcare Analytics and Logistics and is known for his applied research at the intersection of OR, AI, and healthcare systems. His early work focused on logistics and workforce scheduling both in industrial and healthcare settings. Over the years, his research has evolved toward developing decision support tools with real-world impact, particularly in the planning and optimization of health services. Outside academia, Louis Martin has co-founded and advised several mission-driven organizations, including Gray Oncology Solutions, IVADO Labs, Kaster, and PemPem. He serves on multiple boards and is an active member of Ange Quebec and Creative Destructive Labs, where he supports science-based ventures focused on societal impact. Louis Martin, thanks a lot for accepting the invitation.
Thank you.
Yeah. So, Louis Martin, you are turning 50 this year. Since you are the son of Jean-Marc Rousseau, the former director of the CRT, it's not hard to guess that you were born and raised in Montreal, right?
Yes, absolutely. Always been on the island, except for a few months here and there.
Right. I usually ask guests to say a few words about their parents. I know your father is a well-known figure in the OR community, especially in North America. But would you mind telling us a bit about him?
Yeah, so my dad, Jean-Marc, was had many hats over his professional years. He, when I was born, he was just out of MIT as a grad student and started in Montreal as a faculty in the computer science department, where he built the Center for Research and Conversation during his year as a director there. So he co-founded a company called Giro around also the time that I was born, which grew in parallel. When I was in high school, he eventually left the university and went full-time working for his company. It was a few years before I actually got to go to the same department he used to be teaching. And so everyone knew me from when I was young, and especially everyone knew him as well. Eventually, after 10 or 15 years in his company, went to become the head of a transfer research institute called Cyrano, which is more doing experimental economy. So he headed that, worked there like a vice president for about 8-10 years, I think. And during those years, he also co-founded some other companies, worked as an angel investor, and eventually retired for that for a few years, and then eventually went back again to university as a director of transfer for IVADO, which was the huge institute we have on AI here in Montreal. And he ran that until, I guess, 2 years ago when he stepped down when he was 75. So I think now he's done, but who knows?
Yeah, incredible. And how about your mom?
So my mom was an audiologist, so she tested for ear condition in the hospitals. She worked in 2 hospitals with numerous doctors. She was really driven about efficiency and caring about the patients, but also caring about giving patients what they needed, and doing that efficiently. So they were known for doing the highest efficient clinic in the Montreal region. So.
I think I can already guess, but could you talk about the main influences both of them had on your upbringing?
So we lived in a very quiet family in a quiet suburb. So that was. There was peace and no drama at home or anything like that. My father was traveling a lot, of course, but when they got separated, he protected more time with us, so we would know him and have like at least one dinner a night and weekend time with him. But both parents were extremely very supportive of all we wanted to try and attempt in all our endeavors. They were a cheering fan of everything we wanted to do. So we felt loved and cared for, and it was a good family.
Great to hear. Are you an only child?
No, I have a sister, which is 3 years younger than me. She's an occupational therapist. So it seems all the men in the family go technical stuff, and then the women go and do healthcare stuff. So.
Yes, but I mean, you're doing healthcare anyway, so
yeah, exactly. But not from the caring aspect. Yeah, but not from the caring aspect. On the caring side of things.
Yeah. And you already gave a hint, but how was life in Montreal in the 80s and the early 90s?
It was good. I mean, I don't think I could have asked for more. It was when I was young, we lived in a very, very quiet street, so we could, play games and either hockey or whatever, soccer on the street. Basically, there was no cars. We could, bike to school. I could bike, 15, 20 minutes to see friends when I was, even in primary school. So it was a very, very safe place. Going into high school, I think it was a bit too quiet. It was complicated to go anywhere because you tried to go out on your own, and then getting to the first bus was maybe walking 15 minutes, which is in Montreal weather, not necessarily that nice in the winter, but that was part of our who we are. But then we started to go out as teenager, and Montreal is very safe, so you could go out, maybe not as teenagers, but as young adults. Let's say we could go out in bars. And we were 18 and stay until very late in the night. And there were good public transit system to bring us back home. And then there was also a very safe environment. We didn't fear about anything.
Yeah, you mentioned winter. You come from a family of skiers, right?
Yeah, so I think even my granddad started to ski when he was 3 or 4. So as my dad, myself, my sister, and all of our kids typically, get on skis when they're around 3 years old. I think it's kind of the family religion. Some people either pick hockey or skiing. We're typically on the skiing side of the force, or you can ski like 3 generations at the same time together for a whole day. It's a nice family activity. You can do it, throughout the world and see and explore spaces with that. So it's a beautiful sport.
And talking about music now, did you play any musical instrument?
Not much. I think I was introduced to saxophone earlier on, and I tried it for, I think, 2 times. I gave like a 1.5 year attempt to it, and later on with my daughter, she was picking guitar classes, and I tried to get her to be motivated. So I tried to do that with her, and I picked up the lap steel guitar, and I worked on that, and I kind of was looking at the optimization problem of moving my hand on the strings more than the beauty of the music it was producing, and we did a show, and I realized I enjoy being on stage and doing the show, but not so much producing the songs with it. So I think I had a much more technical view on the instrument more than an artistic one. Or I didn't feel I was expressing myself in any kind by producing music. So I guess I don't have, if there's a musical gene, I just don't have it.
You did some research involving constraint programming in music, right?
That's true. When I was in, I think a postdoc, I spent some time in Paris when there was with somebody else doing constraint programming at the time, and they were studying African rhythms and they were on PemPems, I think, and they were to understand the structure of them, and so they were looking at theoretical way they could enumerate that, and I thought, well, that's a simple constraint programming problem, so I could just write the problem, and then we got it in like a day of work, and then we wrote a paper on that in some music conference, I think, or yeah. That's my claim to fame in terms of anything related to music, I guess.
Yeah, I myself had an experience working on the interface between optimization and music. In our case, we worked on generating guitar solos for 12-bar blues. It was a very nice work, and we published in the Journal of the Operation Research Society a while ago. It was probably one of the most fun things I've ever done. And what artists from the 80s and 90s would you include in your music playlist?
I think at that time it was a kind of a mix of like Eric Clapton and Genesis, Bon Jovi, or Canadian English like Bryan Adams, stuff like that. And then some Quebec people like Daniel Bélanger, Jean Leloup, other bands, I forget the name there. But it was just more like a mix of that stuff, some English stuff like Styx as well and things like that. Yeah, kind of a mixed influence, I would say, from the English continent we are on, and kind of the Quebec bubble where we produce a lot of singer-songwriter that have a lot of talent and that were really engaging, especially like it was the independence years and stuff like that, right? From the referendum of 80 to 85, a lot of music was around Quebec independence and all that stuff. Not too much of French European music, I realized. I think I got to that later on in my life, but that wasn't we were not exposed to that much. That stuff when I was young.
You mentioned that you enjoyed performing and being on stage. You were involved in theater, correct?
Well, not that much, but I remember that the like we call it art dramatique in French, I guess, like drama art, as opposed to visual arts or music, or I don't know what would be the other one. which I really hated when I was in high school. The drama part I thought was fun. I almost put more energy into that. And later on, when I was just before going to college, there's a school here called CGEP, and in that we had one French class was actually building a theater show ground up, and I was one of the actors. I really enjoyed that. We had a show with multiple nights. It was a great experience. I really enjoyed that. So yeah, I think maybe that's why. I mean, I love teaching or giving talks of it as much as you get this kind of stage feeling that you can get from that, without necessarily having to play somebody else's character. But definitely, that's the form of art, let's say, that appeals to me the most.
Yes, that's very nice, especially in our field where so many of us have stage fright. And what are your preferences regarding books?
That changed a lot over time. I think when I was young, especially in high school, when I started to read a lot, I really enjoyed the sci-fi books, science fictions. I read like all the Foundations and the Star Trek stuff, and most of the book had to be about some kind of futures interesting thing. Then I got more into like spying novels and we say in French roman policier. I don't know, you're hunting down for the criminals. And I really enjoyed the novels at some point, because I think also I was kind of stressed out, so that was kind of giving me a break in my head and to escaping in another world. Lately, I'm more into storybooks or bios of famous people, and also some business books, because I recently started to teach business classes, so I think I need to be a little bit aware of what's been written in that field. So I'm kind of going through those in diagonal to see what's in there.
Yes. Did you perform well in school?
Yeah, I think it was good. I was not the best student in the class, but I think I was clearly among the best students in the class, maybe for let's say top 5 people in the class, something like that.
Wow, that's good. Did you have any summer jobs during high school?
High school, no. I think high school in Canada is 1 year less, right? So we finish when we're 16. We used to travel a lot. So typically I would do like a couple of weeks of traveling with my dad. And then one thing I would do is also volunteer at summer camps. So I wasn't getting paid for that, but we were doing summer camps for the poor children of Montreal, some of which would never go out of the kind of the concretes of their neighborhoods. And we would bring them to the outdoors and some lakes where they would spend like a few days or a week. And they would take rotations on being camp advisors or monitors. I don't know how do you say that in English, but we would do that in the summer. So I did that when I was in high school. Then the year after that, I worked at the grocery store, just packaging the bill. That was horrible. I did that, and then they wanted to, I think they feel I wasn't enjoying much, so they just gave me even a worse job. They put me outside to help the customers pick up the flowers, and that was even worse. Like they would just, some of the ladies, they would come and just name the flowers they wanted, but I was totally clueless, so I couldn't tell exactly which one was which. So I had to get them to point, and you would do nothing all day except water the flowers until somebody would eventually come and buy them. So that was so boring. And then eventually I got hired at my dad's company to do some, let's say, basic technical stuff. That was the years that it was pre-GPS or Google Maps or anything. So you would get snapshots from satellites of the road network. But the crossings were like, you could flip 90 degrees on 2 highways, one above the other. So you had to correct all that. So I would go and get the real maps from the government. And then I would superimpose the satellite. And then with the software, I would just click, manually fix all the interstate exchange. And in the second year I did that, then I knew how to program, so I could even script about part of it. And that became a little bit more fun. It was an interesting job because I could go to have lunch with people doing OR. For a job, right? And I would spend some time with these people. They were much older, but they were fun. So we would just go out to the restaurant every Friday. We would go eat fondue every single day for, I think, 20 years. They went and have fondue on the same Friday. And so I would understand what is the role of an OR specialist, what time of problems, what challenges. And eventually, that kind of convinced me that OR and computer science looked more interesting, let's say, than aerospace engineering, which was kind of the hot thing. Like good students were all going in aerospace engineering, but I thought that seemed more fun.
Right. I'm tempted to think that you chose to study computer science at University of Montreal in 1994 because of the nature of your summer jobs. Am I right?
Yeah, like I explained, this is because I was exposed to that. I knew what it was, right? I knew what computer science was and what you could do with it. So I felt more natural than just doing basic engineering. And as someone said later on down in life, and I think I realized then, is that computer science is not, let's say, astronomy is not the science of the telescope. And so for me, computer science was a way to have an impact on the world and do things rather than actually working in the computer. And I think as a high school kids, we were thinking, oh, computer science, solves computer problems. So they actually open the computers and work the whole day in the computer. And so that didn't, it felt better to work on airplanes or rockets than working on the computer. But once you understood that actually you work on what you can do with computer, then the whole world opens up and then you see all these applications. But we didn't get in the 80s or 90s exposed to what really was computer science until you were kind of in the know, and that summer job gave me that vision.
Yes. Many people nowadays still have the, let's say, inaccurate impression of what a computer scientist can do or computer engineering. They think that you're just locked up in a sort of a lab or in an office and you don't get to interact with the real world or socialize. So I think that's a misconception. And in your case, it's good that you're sharing what motivated you to study computer science. It's exactly the opportunity to make a difference in the world. And that is very, very nice. What were your grades like at university?
Yeah, they were almost perfect because then I was, computer science seemed to be easy. And there was a little bit of math in there that I was also good at. And the other people that were going in computer science because they like video games, for example, or other kind of non-scientific motivation, thought it was really hard. So that kind of discriminated most of them for getting good grades. But I was good with theory side of it as well. I was probably not the very best programmer in there. Some of the other kids were way better programmers, but the program was much more about what you could do with it and the computation time, the complexity analysis and all that stuff, and I could do that. So yeah, I think I maybe got 2 grades, which were not perfect on my whole undergrad. So yeah.
Very impressive.
That was important, yeah, to get scholarship. That was because there was tough financial years for the government. So all the graduate school scholarships were basically you had 1 per year, and so you had to have exact perfect grades to land one.
Yeah. And did you have the chance to participate in any research project at that time?
Yes, my first 2 years. In the first year, we did a research project with an OR laboratory that was working in collaboration with an hospital, and they were doing like on-call lists for the nurses. We did that with another undergrad student and work with the professors that helped us do the algorithm, and we did the whole software. We did the whole prototype around it. It wasn't Turbo Pascal, but you had some colors and some ASCII-based screen where you could see which nurse you should call when somebody was sick, and then you would not violate the collective agreement. So we spent the whole summer doing that and interviewing the nurses, the people, spending some nights there, seeing what they would do, and then playing around I think we did probably like 95% GUI and then or front end we would say today, but and then 5% the algorithm and so on. But it was a good experience to see what it takes to actually bridge the real world conditions and objectives of the people who have a problem to the actual algorithm and system that works. It was at the end of when we finished that they couldn't use it because we could not support it, right? So we could not answer the phone if they have any problems and so much. And also realized that what's important in the software, we spend 80% of the time changing the colors to match everybody's request instead of playing with the algorithm. So realized that the value of the visual. But in the end, we had to let it go, and they bought some other software that was still violating the collective agreement, but at least was supported by a contractual agreement with some company.
Yeah, but that experience was very enriching, I would say, because you were starting and already having the chance to see the other parts required to put some software-based solution in practice, as opposed to just modeling or designing an algorithm, because there's a huge gap, right, between theory and practice.
Yeah, I think I kind of subconsciously understood that my very first year undergrad that there's a difference between a university project and commercial software, and that there's no easy way that one can do something within the wall of the university and make that continuous life. I mean, I got much more depth around that later on in my grad studies and faculty life, but I kind of knew that if I wouldn't do that again in the same format. I would need to think otherwise. When you start something, how is it going to end, really? Because for me, it was kind of a surprise. Oh shit, I never thought about that. But actually, you should think about that, like even before you start coding the first line.
Yes. And when did you learn about constraint programming? I know you're an expert on the topic.
It was kind of a random circumstance in a sense, right? Second year, I thought, okay, I know all this stuff about OR, but there maybe I should do something different from Jean-Marc just as a principal. And we had a very good faculty in computer graphics. It was the year of Pixar's Toy Story came out. So big year for computer graphics. We had a company here called Softimage, was sold for over $100 million to Microsoft at the time. That was in the news. It was the first big exit from anybody. So if you wanted to get rich and worked on cool problems, computer graphic was the way to go. It was a lot of math and CS, so I was pretty good at that. And I decided, okay, this is what I want to do. And I talked to the faculty. I got a scholarship to work with him, but then the government slashed all scholarship, like something like the 5th of May. And so I basically was two weeks before the end of the semester. Or actually, no, it was post the end of the semester. I was about to start, and then I had no more jobs, no more summer job. And then people from the CRT then said, well, we have a bunch of projects. We have this thing. We have this PhD student that did a model for a traveling salesman problem on constraint programming, constraint logic programming was called at the time. And we have some project around that involved like recoding something in Prolog in C++ and seeing how it was working. So I didn't have much alternative at that point, so I took that job and discovered constraint programming, and I really, really enjoyed it. So yeah, I stick with that. After that, PhD student called Gilles Pesan became a faculty in Polytechnique after, and then became my PhD advisor when he was hired.
Mm-hmm. It seems that you feel more comfortable working in discrete math rather than in a continuous space. So I think it makes a lot of sense when you think about
I think I always joke that my brain didn't come with a continuous coprocessor. Basically, I really think of everything in a discrete space. So that's why I really enjoyed constraint programming, because it comes from inference, and you manipulate combinatorial objects, you combine combinatorial objects, you can do a lot of math around that, but doesn't involve too much derivations and integrals and all that stuff, which I remember I took a class with Yoshio Vengio in '98, I think, on machine learning, and we coded, like we had to encode the neural nets ourselves, right? Every single line of it. There were no libraries, and derivating through these hypertangent functions and stuff, I really hated that. I could do it, but I had no fun doing that. And I think if the ReLU activation function would have been invented by then, maybe I would have my life would have been as a machine learner person. But all this trigonometric function that you have to do the math around, I really did not like that. And then in constraint programming, you were at these building blocks, and then algorithmic complexity was important, and how you would combine them, and that really appealed to me more. I had much more intuition to do that, and so that's why I kept with that as a grad student.
I think in your case you might not enjoy that much, but the knowledge stayed, and especially when you think about computer science students and computer engineering and those working in those fields, I think coding a neural network at least once in your life is a very important thing. At least to get,
probably. It's the same thing for stochastic things. I can do them. I'm not, but I don't think I have the best intuition. There's the things that among the things that you can do, there's the stuff that you understand and that you can work with people, and then you can implement them. But if you don't have really a deep intuition of what's going on, it's difficult to push the frontier or know or what will be the interesting research topics or where you have a chance. And I think in most of the continuous or stochastic environment, I can do the stuff, but I don't have like the deepest intuition, which I think I have much more on the discrete on the discrete side or combinatorial side of optimization.
Right. That works in various fields. For example, in music, one can play, for example, the drums and be very comfortable, in percussion instruments. But when it comes to, let's say, guitar, you can strum a few chords, but you know that it's not very take the pleasure. But then at least you can understand what's going on. And if you're thinking about a band or a group, that will work, right? It helps developing good music. So when you're working as a team, you might not be the most, let's say, knowledgeable person about stochastic optimization or neural networks, but if you understand the basics, and then you can provide your own input and you can have a good conversation, productive ideas can come out. So I think it's more or less the case. And I think you do that extremely well, by the way. And I see that you know how to make the most of summer periods. What do you do in your third year?
Yeah, another one. I think I need a break. So we, with my best friend, actually, we went to Europe, and we spent the whole summer there. And I think in 81 days, we attended 2 conferences and visited 55 cities, something like that. We had unlimited rail pass, so we did the whole continent basically, like a huge TSP of the whole thing. That was fun. That was a lot of fun. Yeah.
Incredible. Did you go to Eastern Europe too?
We went to the Czech Republic. I think this is as east as we did. We got the whole thing subsidized by the Quebec French Alliance or something like that, because we were going to see conferences. I think I also went to my first CP conference, which was the French days of constraint programming. And I remember it was the summer in Orléans. It was like 30 degrees. And it was my first conference, so I put a suit, right, with a tie. And it was a French CS conference, right? And so everybody was in flip-flops and shorts and T-shirt. And I remember my friend going here with no black ties, looking, oh shit, we missed something.
Wrong dress code.
Yeah, exactly.
Yes. I must confess that I myself never wear a suit or a tie in a conference. Yes, I think that's.
I did once, except and a few times in Asia when if you give a plenary talk or something.
That's different.
But otherwise, in pure computer science conference, no. I was in a conference once when it was an AI conference, and 2 guys I know in the elevator. One said to the other, "Oh, I see you were wearing your dress T-shirt." So.
That's very nice. You had an issue with your vision in your early 20s. What happened?
It seems I have some congenital disease that affects the mitochondria in the system, and only the visual cord can be affected by that. So I kind of lost the sight on my eyes for about 6 months to a year. It was kind of blurred. It was a bit frustrating because it's blurred exactly where you're looking, and everything else is clear. So you can move around, but you just cannot read, and you don't see the face of the person you're talking to, so you cannot read on the lips, and you cannot read anything or watch TV or do anything. But you're not blind, right? So you can move around, you can just open doors and stuff like that. So it's kind of it was quite frustrating. Fortunately, by some random chance, it came back to, I would say, mostly normal. Not 100% perfect, but let's say 95% perfect. So it's unfunctional, let's say.
Yeah, that's already very good.
It's my excuse for not being very good in tennis, basically.
And Louis Martin, did you originally plan to stay in academia?
No, I never thought I would teach, actually, or be a researcher. I just went with the flow. When I finished my undergrad, I went to the job fair. Nothing seemed very appealing, and I thought, I can always do that later. And had this summer project on the TSP with constraint programming that could be turned into a master. So I thought, well, I'm going to just do that and see. And by some also random chance, I found 2 scholarships that could be combined. So by combining those, I was making as much as my friends who were working, but I was hanging out in school, having summertime, doing research on what I wanted. I had no boss. And my advisors would give me a lot of freedom. So I thought it was, as long as I can basically make as much money doing that I can do as working, I can always delay getting a real boss. 1 more year and then 1 more year. And then I could, I was not tempted, but I considered maybe I should finish my master and apply for a top school in the US, something like that. But then I was just going, and I was was kind of relaxed in Montreal doing this, and I just kept at it and I could transform my master into PhD, and then I wouldn't need to take any more classes, and my first project would count as and then this way I could do my whole PhD in 4 or 5 years, including the master. So I just kept doing that until I almost graduated. Then I thought, okay, now they will kick me out, so I need another plan. And we had started a company with a friend, so that was an option. And then somebody called me because he was retiring from the medical school, the medical school of the University of Montreal, and they have a unit called healthcare administration, and he was giving an OR class in that, and he said, "Oh, we need somebody to do that, so you could get hired as a faculty here, and you would only teach that class." So I went in the process, and that looks like a good job, right? I would teach one class a year, and then I can do again basically whatever I want. I started the process, and then they offered me the job, but I kind of felt that the dean and everything, they were all doctors, and they didn't understand really what my research was about, and they didn't care. They were seeing most as a teaching position, and it would be kind of semi-hard to get good students. You would rely on colleagues. In the process, I thought, well, as I'm applying, let's apply everywhere. And there was a position at Polytechnique that opened up, and I turned out to get that one, and then chose to go to Polytechnique, I guess. And because I did that, I didn't do any job interviews or anything else. I could say, oh, that looks good. I can more or less continue to do the same thing. And then I had a company on site, so I can just kind of see whether that can be compatible or not. And I'd say, well, I can always quit in 2-3 years if I don't like it, and can go work then.
So let's break down a couple of these directions. First, as you mentioned, you began your master's studies in 1997, which was later converted into a PhD. And I know you worked with constraint programming during your PhD, but what specifically?
So in my PhD was about how to combine constraint programming and classic operations research to solve transportation problems. So we did, at the beginning, we started with this TSP implementation, so that wasn't a paper, but just to get going. And we work on the VRP. So we did basically, one paper was around meta-heuristics for the VRP that would use constraint programming as a reconstruction engine for a large neighborhood search. The second paper was column generation. So we used constraint programming as a pricing algorithm for column generation. That led to a sub-paper on stabilization of constraint of column generation. And then the third problem was around synchronization and vehicle routing. If you have, at the time we could only do real time because the technology wasn't fast enough. But so if you have to accept real time transportation event for, let's say, on-demand transportation for a disabled person, for example, and then how do you synchronize fleets or services? And again, doing that with constraint programming in some kind of online optimization fashion.
Yeah, very interesting. Did you struggle to publish your early papers on constraint programming in OR journals?
Yeah, there were very, very few OR journals that knew even what constraint programming was. The constraint programming community is a CS community, so they only or mainly publish in conferences. So they have a journal called Constraints, which is a good journal, but it wasn't, people didn't care as much as to get their paper in the big conferences. In the OR world, they didn't understand what it was until some point where actually iLog bought Cplex. And then everybody said, what? What's that? And then they have to understand that actually constraint programming has just bought mixed integer programming, linear optimization. And so then everybody woke up to what this was. And over the course of the years that followed, then people paid attention to CP more. And I think there were 1 or 2 journals. Then eventually, I think informational computing was one of the one that had an area around constraint programming for a while that really helped papers to get accepted. And but yeah, at the beginning, you wouldn't dare really send a CP paper. They wouldn't understand that the writing of the model uses English words and stuff like that, and it requires you to understand each of these global constraints, what they do, and it wasn't self-contained if you were not from the literature, so it was very hard to understand.
Yeah, you mentioned that you were starting a company with your friend. That was part of a side project at the time, right?
Yeah, so when I was in my last year of of PhD. For some reason, I had to wait for 6 months, or I couldn't do tests. I couldn't run tests because I didn't have the libraries, and I need the university to renew them from iLog, and you had to pay them at a time. That took a while. And so I worked on a small side project, some physician scheduling, because some other people were working on that, and I thought we could do it with CP. And my friend had a company that was selling computer architectures to hospitals and stuff like that. So he also knew that some people had challenges doing schedule. And that was around the time I also got my first kids. And whenever I went to the doctor, they say, oh, we don't have the schedules yet, because I need to do the schedule and I don't have the time to do the schedule. And it was so I couldn't book it. And so at some point I told her, oh, let me help you now. I have this toy project I have this paper I did 2 years ago, and my friend has a company, so he can support the software because he has staff. And then you have a problem, so let's put together. We got a small grant from the government to hire like a UI person to make a front end on the algorithm, and we hosted that in my friend's company, so we could have something that would send invoices and support and hire some people. And we got our first contract for $5,000 a year. We felt them, we're on the road to become now vastly famous and rich and so forth with that. But it existed, right? So it's like you go from 0 to 1. Now you have one customer, so you need to hire people. And then if you have hired people, you might as well try to get more customer. And the journey started there. And eventually we built slowly on that.
I see. So we discussed about papers and so on. Is it true that you have difficulty writing correct English?
Oh yeah, not only English. I think it's maybe even worse in French. I don't know. No, I think now there is a diagnostic called dysorthographia or something like that. And I don't know, in French it's dysorthographie, where you actually have some problems with grammars, and I also struggle with that. It was a nightmare when I was in high school. That's why I was also very good in computer science, because there was no points given to you on the quality of your writing. I mean, I think I can write a decent text, but I just cannot get the spelling, and then the grammar on my own thing. I can correct somebody else's text and I will catch all the mistakes, but on my own thing, I just can't. It's been 50 years and I still really horrible at it. But fortunately now the tools are way better. They just correct your stuff, and it's been easier and easier to get the software to correct your mistakes. So I used to be called lazy, or you don't reread yourself, or just pay attention. But after some decades of that, I just realized that that's the way it is.
Yeah, you cannot help it.
I tried, but then now I just use tools. Yes.
Yeah, I understand. And Louis Martin, what happened exactly after you completed your PhD in 2002? I mean, did you go straight?
Before completing my PhD, I needed a plan for that year, and that was even before I got the jobs from the medical school and the Polytechnique. I had organized a 2-year postdoc in Italy with funding from the Canadian government. So I was leaving in January 2003. I was leaving for Europe. First in Italy, and with some time in France as well, back and forth between these two places. The medical school, they were happy I would do like 6 years of postdoc or something like that. That's kind of what they do in medical school. But Polytechnique really had urgent teaching needs, so they had me cut that to 1 year. So I did the 2003 year, now maybe 2/3 in Italy, and then 1/3 in France, and the summer here, I think, or something like that.
Uh-huh.
When I graduated, I got married and we bought a house the year that I graduated. So I didn't want to leave for a full year. So I kind of did back and forth and spend the summer here to work on our new house that needed every renovation.
Right. In Italy, you worked with Andrea Lodi, right?
Andrea Lodi and Michela Milano. Originally, my postdoc was supposed to be with Michela Milano. She was really but then Andrea was working there. And because in 1999, they came with a super interesting paper with another student of theirs at the time called Filippo Focacci, which is now has a company in France called Decision Brain. They work on combining really mathematical programming and constraint programming, especially something called reduced cost filtering, where they would compute the duals with the mathematical arguments and then inject them in a combinatorial fashion to kind of do, let's say, a combinatorial version of variable fixing. And I thought that was so exciting, and that's where stuff was happening, and that's why I went to work with them.
Right. So you became a faculty member at Polytechnique Montréal in 2004. Did teaching come easy for you?
No, that was not really a nightmare, but it was kind of a panicking moment at the beginning because I had never, like you don't know how to do 20-minute talks, but you spend a day to prepare a 20-minute talk. So now if you multiply this, if you want to give a 3-hour lecture, you're not going to spend like 6 days per lecture. So I kind of, I had a sketch idea and I had these sheets of paper where I think, oh, I can do, so many hours per one, per sheet. And I had my estimate that I could do maybe 5 hours with what I had prepared, but it was all done after 1 or 2 hours. And then I had the rest of the 5 hours where I had nothing. The first week was horrible. I didn't have my pace. I didn't know how to improvise. I remember once I had like 1/2 sheet of paper and it's still an hour to go. So I had no clue of how I would survive that. And then the department said, oh, actually your class is just 2 credits. We just figured that out. So you're going to give a second half of a new class, the second part of the semester. So now I had to build something ground up on top of that. And then that was the semester my first daughter was born. And there was no such thing as paternity leaves or anything like that. They would say, oh, if you need to miss teaching because your kids your wife is delivering a baby, just swap classes with somebody else, right? And then you teach double a few days after, which is not a solution because for me, it was my first semester. So I didn't have the material. I would still need to prepare everything. So it was zero break.
So the next 2-3 years were really crazy for you, weren't they?
Yeah, I think the next 2 years and a half, 3 years were horrible because my second baby, they were very young. And I mean, they were very good babies and the whole perspective, I think they were still sleeping and things like that. But no, you had to care for them and be home. And so you couldn't work that much at nights and on the weekend. And the company was still small. So I had to do everything like the income tax, the invoicing, the customer support. And then I had to build I think I taught maybe 2-3 different classes that one was already made, but 2 I had to build ground up. Yeah, I don't remember. I didn't sleep much. I was sleeping in my office, basically. I was rolling my winter coat on the floor and napping in the afternoon to catch up before class and stuff like that. I kind of lost pieces of those years. It was just, I think it's not necessarily the sleep deprivation rather than the huge stress around too much new stuff going on, like a new parent, new faculty, new entrepreneur. And all of this synchronized at the same time was just, was very intense, yeah.
Yes. And talking about crazy things, in 2006, you published a paper titled On Global Warming, Flow-Based Soft Global Constraints, which gave you a bit of a headache, right?
Well, that was fun because it was it was a paper with my very good friend, Willem Jan van Hoven, who was visiting Montreal at the time, and Gilles Pesan, who was a colleague then, previously my PhD advisor. And a way to make global constraints and constraint programming soft. And some people would say you kind of softening or warming the constraints. So Gilles thought, it's warming and it's global, so let's call this global warming, right? So it was 2005 or 6, I think we wrote that. And I mean, global warming wasn't, people were talking about it, right? But it wasn't the crisis we are in today. And so we published that. But after that, like in the 2010s, I get like 1 request a week to referee climate paper because people looking for working on global warming stuff in chemistry and weather climate and oceanography, and they want me to review all that stuff which I know nothing about. So I thought, okay, it was a good joke, but
That's very funny. I find it very amusing. And between 2008 and 2012, you brought together the fields of formal languages, mathematical programming, and constraint programming to develop a powerful technology to efficiently solve problems related to call center shift scheduling, employee workforce, and so on. Could you elaborate on this, please?
Yeah, I think those are the nice years where kind of everything finally came together. In the company, by then we were a bit bigger. We had a bunch of customers that were doing traditional. We were solving their scheduling problem with traditional NIP. But we started to see new customers that were more complex, like call centers or retailers that want to really micromanage what everybody was doing at the 15-minute time interval. And MIPS couldn't do it. And then Gilles and other people had worked on formal languages, like regular languages, and then some other people were working on the grammar, context-free grammar languages, stuff that came from compilation theory and formal language assembly, and how to build constraint programming model on that. And so I kind of saw the fit between what these things could model and what needed to be solved in industry. But the CP wasn't fast enough to actually solve this problem. So what we did is we bridged this knowledge into integer programming. So we brought the formal languages to integer programming because that could sit on top of Cplex and solve the commercial problems we had. And so we had a stream of paper around that, some of them in management science and another very good journal where we get a theory. And there were some papers from the 90s that worked on that theory, and there were a couple of ideas of different models, and we were able to kind of bring them all together and show their equivalence from a theoretical point of view of context-free grammars and hyperflows and stuff like that. So we made really theoretical breakthrough on the field of multi-activity shift scheduling, and then we were able to productize it in the software and then have customer use it, and the company really jumped a level at it because we were able to have much more wide base of customer and address more challenging problems and so forth. So we had a couple of very good PhD students and colleagues. Marie-Claude Côté is one of which, and Maya Restrepo worked on that, and colleagues like Bernard Gendron, who's unfortunately deceased today, and Gilles Pezin and other people pioneered this work as well with us, and Claude Kiemper, which is a faculty now in Université Laval.
Mm-hmm. Is it correct to say that all that scientific advance helped the user experience when, for example, creating an instance of a problem?
That was a nice thing of context-free grammar. So it seems that sometimes you say, oh, the more complicated it gets, no, the more complicated it gets, but at some point it's kind of reverse. Like you would take a model that we have this presentation we did over the years with Bernard, where our first attempt at solving a tiny problem with a MIP ended up in like 5 pages of complex equation. And eventually we were able to simplify it to a nice graph and saying, oh, a network flow in this graph gets rid of half the math, and then you can just model the problem and it solves like a couple of orders of magnitude faster. But designing a graph in the software, like you get the user, oh, you model your problem as a deterministic finite automaton, right? And here's a Corel draw or another draw main and do circles, and that doesn't work, right? So it was moving to a graph-based model was extremely powerful from a NOIR perspective, but it was useless from a front-end or user perspective. The context-free grammar was really the holy grail on that, because you have this non-terminal, and you have this hierarchy, and you build. And so we were able to basically port that in XML, and then have define something like the notion of work stretch, and then your user, they could just have their building blocks, and then the grammar compilation would just crunch everything. Then from there was already theory how to build move it in a Chomsky normal form, and then create the whole grammar graph. And then from there, all the paper kicked in, and we were able to build a MIP, and then eventually build a column generation algorithm on top of it, where basically it's column generation where the pricing is a multi-commodity hyperflow problem. And so basically, so we never published that, but actually what we did is extend column generation to the hypergraph, hyperflow paradigm, basically.
Yeah, it sounds very impressive and high tech, even to this day.
No, but even to this day, I was a plenary speaker, I think, in the PATAT conference on timetabling, maybe in 2018. And that stuff from 2010 is still unbeaten, not even close. So it's like nobody, I think it's that people got afraid of grammar. They kind of read through it. There was a bunch of symbols, and they thought, oh, maybe not. And nobody really jumped into that field. Also, I've kind of been dreaming to apply this to another field. And so far, I don't see like another problem like really personal scheduling where that fits. So maybe it was still a very narrow contribution to that problem and not as broad as I thought it could be in 2010. So that's a bit on me as well, trying to find other application of that. But it really kills that application of scheduling people. But yeah, I would still like to find other problems where that could be used for today.
Well, that's an open research question.
Always, yeah.
Yeah. So a couple of years ago, my students and I, we were playing a bit with the OpenShot problem when we came across your interesting Informed Journal Computing paper published in 2012. I'm really curious to know the story behind it.
That was interesting. At the time, for about 10, 15 years, I had students that I co-supervised with the École des Mines de Nantes. And we would typically either supervise one of their students or have a student do co-tutel between the École des Mines de Nantes and École Polytechnique. And this one, the student was called Arnaud Malapert. And the original project was to work on let me recall, vehicle routing with loading constraints. I think that was an interesting topic at the time. Like if you go around and you deliver bulky stuff, how do you make sure you load the truck correctly? So I know it looked at the loading problem, then it kind of said, it's complex, it's open constraint, but I think you can approximate the loading problem with an open shop, kind of on each dimension, right? And so let's try to solve the open shop. And then he really fell in love with the open shop, and then he built all of these algorithms and CP model. And then he said, I can just close so many open instances of the open shop problem. So we said, okay, we have a paper, right? So we just forgot about loading and then forgot about routing. And then he kept on scheduling. And we tried to say, go back, because I was a routing person. I didn't know anything about scheduling. So let's go back to routing. And he didn't care much. He just wanted to do scheduling. And he was a bit stubborn about that. But he finished with a beautiful thesis. And he's now a faculty in Sophie Antipolis, I think, University of Nice or something like that. We still work together from time to time.
The
results, brilliant. These algorithms were very interesting, and the fact he could just kill everything, even as like a first year of a PhD student, that was impressive.
The results from that paper are really impressive. That's I can tell you for sure. So from 2012 to 2015, you turn your research focus to supply chain activities, right?
Yes. So in 2012, the company called Planora was acquired by a company called JDA Software. That was really a powerhouse of supply chain problems. So they were making about $1 billion of revenue over selling 130 products of supply chain. And I think scheduling people, that was a tiny fraction of their revenue. So they didn't care much. And for some political reason and internal fights within the company, we were really not able in the end really to convince them to push our stuff over the old stuff that they had. And so they thought they would use our people, and much more valuable things for them is to work on supply chain problems. So that opened to me the realm of the whole, I call the supply chain candy shop, right? Because every supply chain problem in the world, they add a software to it, or they either add the number 1 or number 2 software that would solve it. It's like anything from warehousing, transportation, revenue management, deliver all forms of deliveries, and everything in inventory optimization. They would have experts, and among the biggest customers, like all the car manufacturers, the paint producers, the retailer, the Walmarts, everything was on their platform. So I just discovered this world and started to work on that. And we grew the team of my previous company. I think we tripled it. And then we had people on robotics and a real team of UX as well. And we endeavored launching the next generation of retail software called Retail Me. And the idea was to use the emerging field of AI and optimization to kind of rethink the whole science behind the retail industry.
Right. You became Canada Research Chair in Healthcare Logistics in 2015. How did you adapt to this new field?
So in 2015, yes, I applied to become a Canada Research Chair in healthcare. The way the Canada attributes, or the school attributes those chairs is a bit political, but for some reason they thought I would make a good chairholder because I could basically build a new field within the school. And so I was kind of in charge of really growing the activities around healthcare. And so I had a few experience in healthcare. The company was doing a bunch of tiny hospital projects, but I wasn't really, my CV wasn't a healthcare CV, was much more a commercial optimization one. And I felt, okay, now I have this responsibility, so I should take a lot of projects, as many as I can, to show that we can have an impact in healthcare. But the problem is that we end up doing a lot of projects where the hospital thought we were consultants and treated our master's students as consultants with timesheets and report progress, and that after a year and a half, we realized that this didn't work because they were not really able to progress, and they saw that as cheap labor. So they were using our students to do stuff that should have been done by their employee, but they were budget cuts. So they thought it was cheaper to get it done by our.
I know.
So after 2 years of that, like the first wave of student graduated, we said, okay, no more. Now we understand the game. We'll work only with people in the healthcare system that have research interests, right? Researchers that care about publishing papers, not necessarily because I care only about publishing papers. I even sometimes much more care about having an impact, but the students need to graduate, and especially PhDs, they need to have papers. So the university cannot be the sole responsibility to extract a paper out of this relationship. We need to have champions and partners into advancing research. And if from time to time there's a well-defined project that could be attributed to a master, then we would do it. But we would set the expectations straight up front that we are not consultants, right? We are here to answer to a question that you don't know the answer about, and then we will set the pace at which we are going. And that changed the field. And so the first year we did like amateurish mistakes, like hiring 10, 12 masters in the first year, and then they all graduated at the same time. So you have 12 master thesis to read within the 2 months and get all of them to present to juries. So then you don't have enough faculty members to be on all those juries, right? So this was a nightmare. And after that, we understood and it's okay, let's readjust a bit. And so I've been renewed now until 2030. And at that time, then I cannot renew anymore. So I've had about 15 years of that thing. And now we organize the chair around 3 pillars, one of which was home care. And I can talk a bit about that later. And then the other one was really cancer care, because we also have had some relationship with the hospital by then. And the third one was kind of a potpourri of hospital logistics, operating room or intensive care, which was always been a bit, let's say, fuzzy in terms of clear definition, and not the main activity. And over the years, we're kind of evolved around which pillar is the most important.
Yeah, right. Could you comment on your home care optimization project that apparently was deployed in practice?
Yeah, that was interesting. It took a while. When my company was acquired, they also acquired another company from somebody named Adrian Schauer, who later, 2 years after, left JDA to found a company around home care logistics called Ilaya Care. And the idea was really to digitize and organize better the field of home care logistics. So I think when there were 5 or 6 people, we started to collaborate with them and see, okay, you'll need some algorithm to route the personal support workers, and we can do that. We had a student that did a couple of papers in that field, and one of which was really a practical algorithm that they could use. But they were struggling at the beginning to build a system that people will adopt and understand what they still didn't understand about home care. And the customers were just so way getting out of the Stone Age in terms of digital world that optimization was the least of their priority by them. And actually, they told me that they switched on the optimization in January 2024. So that's basically 8 years after we give them the algorithms. My colleague Nadia spent some time in the company also in the last 4 or 5 years to help them bridge the gap. So in 2024, they offered it as an option, and a bunch of their customers raised hand and started using it. And I think as this year, it's now part of a platform and mandatory. Like everybody gets it, and now everybody has optimization. And now the company is worth over $1 billion, has 600-700 employees. They're active on all continents. Now they schedule or organize billions of visits. Yeah, it's one of the dominating player in the field of home care. So now our algorithms suddenly will get used throughout the world, but it took maybe 8 years but like I said at the beginning, right? So it's the people, not necessarily. The optimization is the very last thing you can do when all the rest, the front end is fine, the process is fine, the back office is fine. Then you're ready to use optimization. But it takes a while, and it takes really like a whole supporting infrastructure.
Wow. And Louis Martin, what is your involvement with the IVADO Labs?
So during those crazy years where AI was booming, there was a couple of big initiatives in Montreal. And so I think it's important to understand them all, to understand what is the role of IVADO Labs. So first came the Canada Excellence Research Chair, which is quite a big budget that was kind of dedicated to bringing somebody from outside Canada to Canada to build a large research group. So we convinced Andrea Lodi, which was my postdoc advisor, to come and lead this chair. And through this initiative, then they created the IVADO umbrella, which is an institute on top of all the research center in analytics in Montreal, like the machine learning and Mila, for example, and then all the OR centers. And it kind of distributes money to all of these and coordinates them in some matter, especially related to industry relation. Then after that, the government had sprinkled so much dollars on the academia that they felt they should also send some dollars to industry. And they created a bunch of called super clusters. So basically 5 clusters that would get funded in hundreds of millions to help Canadian organizations compete at the world level. And one of which was called Scale AI, which funds companies in the supply chain sector, so that the Canadian supply chains can have tools that are as modern as the American or European ones, and then Canadian corporations can face international competition. So that was a success as well. And now the Scale AI cluster has some hundreds of millions that they need to give to Canadian corporation if they do AI supply chain projects. Problem is that there's not enough staff, right? Where do you find a team of 5-10 people with some PhDs and analytics to do a supply chain project in transportation, warehousing, inventory, revenue management in a large, let's say, oldish corporations with didn't have that much talent before, so they don't have the talent to do it. And so this is where Hélène Desmarais and Andrea created IVADO Labs, which is a non-for-profit organization, basically, which role is to provide staff to these organizations that want to do a Scale AI project. And that's why it was started. So then Andrea called me and Jean-François Cordeau to kind of think about how we would build this and the type of organization. And it grew over time to a team of 150 people, which has about 10 to 12 faculty members that guide the project, and then about a third are data scientists, so people with PhDs, a third are engineers, and a third about business consultant. And the company does about 15 projects at any given point in time on mostly helping large Canadian corporations do Scale AI projects. They have some other activities outside, but I'd say that's the main bread and butter. And so my role as just any other scientific advisor is to work on some projects and help the team use the latest tools, the best math, the best science, double check that we're not bullshitting the cells and we are delivering solid and grounded projects. And then as a scientific director, I'm also involved in this kind of choosing the team and overviewing, like having a global view on all the projects and helping guide the company in what we believe is a good scientific direction.
Yeah, that's a remarkable initiative, and I hope other countries take inspiration from what you guys are doing and have been doing. It is really, really, really relevant work. You are also one of the founding advisors of Gray Oncology Solutions, a company that develops smart scheduling solutions for optimal cancer care operations. Can you tell me a bit about this initiative?
So starting in 2009, I was put in contact by one of my colleagues who unfortunately passed away this year, François Soumi. He connected me with a doctor in an oncology center that was building a new regional oncology center, and they wanted to size it correctly. And they were doing everything with napkin math, right? So many patients, divided by the average number of treatment, divided by the average number, divided by the average number, and boom, we need so many people, so many machines. But there's some stochasticity, right? And you get variance. And the patients, they come for like 40 days in a row. So if you have 10% more patients, you clog up the system for 2 months, right, before you catch back. So you have to think about that. And then we did a random event simulator, and then we realized, oh shit, we need to double the number of people. And then they did, and they were more or less even stretched when they opened. So they said, oh God, no, thanks for this kind of tool that we had, and we get a very good relationship with them. And then we worked on more advanced scheduling things, and then they couldn't really put it in practice because it was too complex. Combine vendors and Danzig from online scheduling and stuff like that, and with no front end anything. So we kind of give them we could distill some advice from what we would see from the algorithm, but they couldn't really use it. So we did some project that also on chemotherapy scheduling, but again, they wanted to use it, but then they couldn't because they were moving from one hospital to the other, so the whole bandwidth was around the move. So that was more or less left like that. And then the pandemic hit, and then they saw a humongous drop, like a 30-40% drop in the number of patients they were seeing. And the doctor said, where are their patients? And then what happens if they come back and when they come back? And so we kind of went back to the drawing board of the simulation. And then we got a grant from this IVADO umbrella that had started a very nice program which would help postdoc start companies. And so one of my postdoc got this grant and said, okay, he came from medical physics, and he said, okay, I think we can do this. And so he had the knowledge and the clinical knowledge of how these things work. And we had worked on the algorithms before, so we wanted to synthesize it. We also had a guest PhD a student called Toussaint Fan that had been working on this. And so we had, let's say, a portfolio of algorithms. So we tried to look at which one would be the best, which could be extended, and we combined some pieces, and then we hired some engineers that would just bridge the gap between the theory and the practice. And so that was starting in 2020. Then we got some there were some scale AI grants against for healthcare and pandemic stuff that allowed the hospital to qualify as well, even if they were not supply chain. And that started the wheel, and then the company got investment, and we built a company which is about 10 people so far. I think we probably have scheduled 1 million appointment in the Canadian
Wow.
healthcare. We have 10 hospitals. One is in the US, and we're looking at deals in France as well. And yeah, I'm quite proud of it because finally, like I said, maybe after 25 years or something, I have an healthcare project that is live and actually doesn't optimize for profit or dollars, really optimize for maximizing the efficiency of the public healthcare investment we have. We could increase, we can save the time by 30, 50, 80% of the clerks, but we can squeeze typically roughly 10%, depending 11, 13% sometimes of more patients in the system with exactly the same resources. Just playing the Tetris better, you can just fit more patients. And it's live, right? It's schedules thousands of patients every day.
Yeah. Well done. You literally got the full package. Should be proud of it.
It took a while.
Yeah. Yeah. And you and Nadia and the other members of your group did a fantastic.
So that was, I did forget my co-authors in there. The students really built the company. We were advising it with Nadia and Polytechnique, and Jan Sudjens from, at the time it was in McGill, now is in Toronto at Princess Margaret Hospital. We kind of provide the advice, and I also provide some advice on the business side. But the students, the company was founded by Marc-André Renaud, which was and André Diamond, which were our graduates from the McGill Medical Physics Department.
Yeah, beautiful interdisciplinary work. I think this is probably the way things are naturally moving. I think many of us have been tired of working on, let's say, classic problems or trying to squeeze the algorithms to improve that 0.5% or 1%. And some of the low-hanging fruits are no longer available, let's say. We have to push the limits and bring fields together. And I think you are a master of doing that. And what has been your experience working on real-life optimization problems under uncertainty?
Yeah, it's still always a discussion we have with some colleagues because when that really kicked in when I was at JDA Labs. So when they bought our company, we were consulting with them, and I was doing a scientific advisor a few hours per week. And they had all of this thing about uncertainty, planning under uncertainty. I gave internal presentations also in India and a bunch of places on that, trying to make them understand the value of planning under uncertainty. And everybody thinks a great idea until you tell them, it's kind of this first stage solution, your routing plan. Let's make that 3% worse. Because actually, when reality hits, it's going to be way better. Then nobody signs on this kind of 3% hit because they think, well, maybe it's not going to happen. No, I lose this percent for real. I might better gamble. Because I think also the people that do the planning are not the people hit by the operations and have to suffer from deficiencies in the plan. I think airline got that before and are doing a bit more on that. Clearly, finance and revenue management, uncertainty is their bread and butter, right? They make money out of uncertainty. So they've incorporated these tools way ahead traditional supply chain. I mean, inventory optimization also as this kind of built in their field. But let's say from my angle of transportation, routing and stuff, we've been seeing papers on uncertainty decades before commercial systems that allow for uncertainty. And now we are doing very advanced method on robust and distribution robust definition. But I think it will still take a little bit of time because this becomes widely available, or general availability, as we say, is still going to lack a bit, because I think it's not so easy to demonstrate the value of that to a manager that's solving a problem. Like we need to do counterfactual tests, right? So to show what the value of that, and these systems are super expensive to build. So it's a challenge.
Yeah, I see your point. Also, it adds a lot of computational complexity, and at times customers, they're looking for fast solutions, and then they might think, okay, you might be providing solutions that are robust from uncertainty perspective, also solutions that are more reliable, and if you think about stochastic optimization and so on. but also it comes with a lot of heavy machinery in terms of math and algorithms. So do you see that somewhere in the near future, these type of solutions will be more accepted by the industry, or there would be still this relatively large gap to be filled?
I think there will always be a large gap because people are pushing the envelope of what's doable. But I also think that AI really helped with that, because AI pushed in the head of the general public that machine could predict the future in some form, right? And so now, especially at IVADO Labs in 2019, 20, and so forth, everybody wanted to do routing with deep learning, and everybody wanted to do everything with deep learning, because they thought it was now everybody wants to do everything with LLMs. But at the time, they kind of thought, oh yeah, AI is real and AI can predict the future. So now they say, oh, if I can predict the future, I can also predict disruption. And though that opened the field to, okay, now we can do stochastic optimization. But again, right, we went back to doing basic two-stage stochastic optimization with a handful of scenarios, like nothing fancy, something which is textbooks from 20, 25 years. But now at least we are able to do it, because there is some appetite from uncertainty. Before that, the problem, complexity means that the solution vendor has more costs, right? You need a bigger team, and then your software is more complicated, so it's more expensive. The problem was really that the customer didn't want to pay really for that cost, especially, and the customer did not want to sacrifice the first stage solution in the hope that the second stage would be paying, because they were not monitoring that. Often when things didn't go as planned, the cost of that wasn't really captured. So they couldn't say, oh, we're going to save operational inefficiencies or disruption. We're just kind of end all in an ad hoc way or something like that. And so they see things were not perfect, but they were not really, the ROI of that was very difficult and to doing like back testing on what would have happened is complex because it didn't track everything. So it's more like demonstrating the ROI of stochastic optimization was kind of difficult. And so from a marketing point of view, it was an extremely narrow play and made it a challenge to sell these things. Now that everybody wants to predict the future, then it's a bit easier, an easier sell.
Yeah. Thanks a lot for sharing these insights. They're very valuable. And you mentioned AI. What is your take on the role of AI in research activities and paper preparation? And what do you see as its implications in academia?
Yeah, I think when we discussed, I recalled a quote by a very famous Montreal songwriter called Leonard Cohen. And when he passed away a few years ago, they had a beautiful ceremony where they highlighted that, where he said basically that poetry is like ashes, basically, is a testimony to a great fire. And so in a sense, you shouldn't aim to do like poetry directly. You should aim to have a great life, and out of a great life or a great experience, poetry will emerge, basically. So when I read that, I don't know when he passed away, maybe a few years ago, it made me realize that my personal view, and I accept that this is maybe only my point of view, is I see scientific paper a bit the same way, right? So if you have a great breakthrough or great research project and you accomplish something, then the paper is just a testimony of that, right? And so you shouldn't be aiming to just do any paper. You should be aiming to do challenging or interesting product. And of course, when you're young, you have to be tenured, and then at some point you might have to be strategic and pick up the low-hanging fruit and get tenured, right? And then get promoted. But at some point when you're kind of safe enough in your environment, I think it's a bit more interesting to shoot for bigger challenges. And out of that, hopefully will come papers. But for me, these are not as important as solving those challenges or answering some of those questions. And I think AI will change a bit the game on that, because there's a couple of papers that come out that you cannot now, there's a bunch of tools that help you write or run experiments, synthesize literature. Probably we'll see an end-to-end pipeline that goes from question to paper soon. There's been evidence that you can train virtual agents that replicate the academic system and then publish referees one another. And these, if I'm not mistaken, were able to produce a paper that was accepted in ICML for an average cost of $10 per paper. So I think producing paper to produce a paper will become easier and easier. And probably yourself with a good day on, you know, and a nice cup of coffee, you can go from an idea to a paper in maybe a month, then a week, then a day, then an hour, who knows, right? But at the point where you can publish so many papers, right? What's the value really of any of that? Right? I can produce poetry today with AI, but what's the value of poetry produced by ChatGPT or Gemini, right? Do anybody wants to read that? So that's an open question for me, right? When scientific papers become a commodity, I think the value will be in asking the correct questions, or like what is of interest for actual humans, right? Instead of because there's probably millions of valid unwritten scientific papers, right? That answer questions that no one ever asked. So what's the value in publishing those if no one ever asked the question, basically?
Yes, very important reflection. And continuing on this topic, everyone is talking about large language models and their increasing impact in the industry. What are your views on this trend, and how can our practitioners benefit from it?
That's a real revolution. I think even more intense than the one we saw with deep learning 6-7 years ago, because it's actually changing the game for a lot of things. It can build software on its own, QA software on its own. It can it can write math model. It can. I saw it. One of my colleagues we had a very, very complex column generation approach. It was a master problem. And said, "Oh, let's write the dual." Well, I'm not going to spend an hour or a day do that. Just ask ChatGPT, dump the LaTeX code. You get the LaTeX code for the dual, right? And you can look at it and continue on. So you accelerate your research so much by this. I have a student now, a next student that's just manipulating AI tools. He's not coding. He's doing very advanced stuff on decision diagram, but he's not coding. He's just getting a bunch of AI agents to work for him. But apart from, let's say, making our life easier by accelerating what we think might be complex, I think it would solve one of these big issues I've mentioned before about the necessity for complex UI or front ends, or what we call in 20 years of GUIs or stuff like that. Basically, the interface between our algorithms or models and the final human that doesn't know anything about math, right? And you need to have some form of layer. And although we've improved in the quality of the graphics over the last, let's say, we went from ASCII to web-based. So that was a huge thing, right? In ASCII, on the 640 by 480 screen, there were a limited amount of stuff you could actually. But once we passed to web-based, right? Though, if you think about the first web interfaces today, okay, we have more pixels because we have higher resolution, and things got a bit more slick and a little bit more aesthetic. But more or less, you still need to train the human to click and input text and use pull down, drop downs, and whatever, right? So UX has really improved as a science. So it was intuition before, now it's a real science. But our tools are still like a 2D panel, right? And although people have played with HoloLenses and a bunch of stuff, like nothing really material is out of that. And I think now LLMs will break this free, right? The user will be able to talk. Because what happens, right, is that the user talks to the customer satisfaction agent, right? He talks to the employee of a company and says, you know what, your software is great for this, but I don't like that. This sucks. This is wrong. Make this look like this. Change this decision to that. He complains, right? Or makes suggestions. And then the company digests that, fixes the problem, enhances, modifies the roadmap, and then you cycle like that. But what if the customer could just speak to the machine? Oh, change that decision, change that color. I want to see this. Change that rule, right? Like in natural language, the way he speaks to us as practitioners. And then boom, the LLM now modifies our algorithm, our codes, rerun the algorithms, produce a new solution that shows that. And then suddenly our user has a conversation with our model. And I think this is the short-term benefits that I see from there, like getting our stuff to be more accessible. I know more affordable maybe, but necessarily more accessible, because otherwise you would need to modify the front end. You would involve a couple of cycles and sprints of development. It takes a while. Now maybe like you have instant customization at any given site. Further than that, AI replacing the algorithm. I think when AI replaces our model, it will have replaced so much stuff in the rest of society. This will be a different world. So who knows? And we're already seeing this start today. I teach a kind of a build your own company class, and I had some guests that have this unicorn company with hundreds of developers, and they're saying to the kids in the class, like, I'm not hiring any one of you anymore because I don't need any more programmers. No, we're done with programmers. We're gonna digest the growth of our company with AI tools. And you have the CEO of Shopify that basically sent a Slack to all of its employees saying, I expect all of you to be using AI every day, right? And I have these other CEOs that basically are going around their company saying, who's not using AI? So this has really changed. The expectation now is that employees should be using AI as a day-to-day work tool. We'll see where that goes. There's this probably tens of thousands of companies were started or founded in the last 2 years in the Bay Area around using AI for work and personal life and everything. There's probably all coding and developing now, but I guess in 2-3 years, we'll see them emerging and we'll see all these new waves of tools, but we're already seeing a bunch of them. There, this company, Cursor, as of today, we're in early May 2025, they're doing more than 100 million of revenue with 20 people, 30 people, something like that. And there's this prediction that we will see this one-person unicorn, right? $1 billion value company with a single employee. We're not there yet, but more people are speculating about it.
Things are moving really fast and it's a bit scary at times. And let's revisit this episode in a few years from now to see how much of it you got it right. So Louis Martin, you met your current wife in 2019, got married in 2024, and had 2 kids. Has balancing family and work been smoother this time?
Yes, smoother, I think, for many point of views. I think the most important thing with respect to my older kids that I had in the early 2000s is that nothing is new, right? I know what's a faculty job. I know what is to be an entrepreneur, and also I know what it is to be a parent. So kind of I'm much less surprises around the corner. We also have a bit more means, so we are able to delegate a bit more than kind of the DIY move we were in the early 2000s. We thought that we as parent had to do every single thing in the house and manage the kid and everything and manage our career. Now we delegate a bunch of the non-value creating stuff around the world. We prioritize spending quality time with the kids. Which I did a lot as well with my first kids. I think in terms of quality time I spend with both generation is the same. It's just that now I can get rid of all the stuff that is non-essential, which I couldn't back then, and so that creates space where I can still have a professional life that is fulfilling and a personal life that is fulfilling, and everything which doesn't fall into this bucket I can outsource to somebody else, basically. So that's kind of our view on things, and that. But I think it's the fact that having done all of that 20 years ago, I was discovering 3 major things at the same time. Now I've been through all of these places a bit. I mean, of course, every company and kids and everything is always different, but the global way you manage this is kind of more or less is less surprising over the years. So yeah, I'm not stressed now, and I can sleep better.
Yeah, I'm glad to hear that. And what are your plans for the future?
So I keep redoing plans all the time, but now I still have 5 years to go in my research chair until 2030. I started to teach this kind of creating companies. So now my let's say my agenda for the next 5 years is to bring my entrepreneurial expertise inside my school, because they are interested in growing their entrepreneurial support ecosystem and the valuation of research and all of that. And I think I can bring some experience to them. So I'm getting much more involved in those aspects of the school rather than just the technical aspect. I'm getting also aspect in kind of how we can support student entrepreneurs, translation of research, transfer of research, and all of that stuff. I just got elected on the board of the school as well last week. And so I intend to kind of bring back what I learned outside the school into the school, let's say, over the next 5 years. And then after that, my chair will be done. And I think at that point I will, and then who knows, right? Like we said before, the world might be probably 15 years ago, I was not thinking that 5 years ago or 10 years down the road, academic job would be very different. And when you think about it, it hasn't changed much, right? So I think maybe if in the 1700s you were writing papers by hand and submitting them by horse mail or something like that. And I think maybe when I got in the job, people started to send papers by email instead of posts. And now we've evolved to Manuscript Central and stuff like that. But the world of academic has not, we have the same journals. Basically, I publish in the same journals today than 20 years ago. It's the same conferences. The model's the same. The grants, more or less the same. Like the system is probably 90% the way it was when I did it, and maybe 80% the way it was when my father was doing it, 40 years ago. But I think in 5 years from now, it's probably going to be a lot different. And in 10 years from now, I think it's going to be totally different. So who knows, right?
Yes,
But my commitment is doing this 5 years and then evaluating where the world is at that point and seeing what are the next challenges.
Seems like a great plan. And to conclude, would you like to share some final thoughts or perhaps provide a takeaway message to our young audience?
Yeah, sometimes when you get later in the night and at some conferences or with some friends, you start to do some philosophy about the meaning of life. And one thing that always comes up to my mind is that I think I see life as a kind of a maximizing. If you trace the curve of the amount of fun you're getting from now till the moment you pass away, ideally you want to kind of maximize the integral below that curve, right? But there is some unknown inverse function in the fact that if you maximize the fun too much now, you probably decrease the down the road fun. And if you sacrifice fun a little bit now, you probably increase fun later down the road, right? But this relation is also stochastic and unknown. And you kind of learn it over the years. But you want to optimize for it. But the end is stochastic, right? Because you also don't know when that's stuff. And so you have to keep an eye on that. And I think this is what I'm kind of implicitly doing, is trying of getting good times as we go, as we say, and not just building for the future, but also not ignoring that you cannot just have all the fun now. At sometimes it's important to work hard to get benefits later.
That's an amazing message. Louis Martin, thank you so much for your time. I mean, it's been really great to chat with you. I learned a lot, and I'm sure the viewers and listeners that made it so far learn a lot from you too. So thank you really very much.
Thank you, and it was a lot of fun to go back and revisit those times. We seldomly get the occasion to do that, and it was fun to do that with you. Thank you so much for inviting me.
And I still have to meet you in person. I hope that happens somewhere down the road. And of course, as I tell to all the guests, if you want to visit us, just have to drop me a line and we can maybe organize something.
That would be great. Thank you.
Yeah. All right. Thanks a lot once again, and take care. And I hope you stay really active, and I'm really curious to see what you're going to produce in the next years. So
yes, of course. Let's talk again. Thank you so much.
Bye. Ciao.